Chapter 8, Theories and Research on Operant Conditioning. The role of the response. When you move, what's a better way to learn the layout of your new neighborhood? To drive around by yourself, or to get a ride share so you can be a passenger? As a passenger, you can focus on observing your surroundings without having to worry about the rules of the road. But then again, in a way, it can be harder to keep track of where you are and where you're going when you're not the one behind the wheel. One question behavioral psychologists have asked about operant conditioning is whether performing the response is, in fact, necessary for learning to occur. Instead of drivers and passengers in a new neighborhood, E.L. Thorndike, the law of effect guy, imagined rats in mazes. He knew from his own puzzle box experiments and similar early 20th century psychology experiments that if you put a rat in a maze, it will explore until it finds the way out or the food, whatever the reinforcer is. If you put the same rat in the same maze over and over, the rat learns the layout of the maze, and you can tell because sooner or later, the rat starts taking a direct path through the maze to the reinforcer. Thorndike was convinced that a pairing of response and reinforcer is essential for learning because a response that does not occur cannot be strengthened by reinforcement, which is kind of the important part of the law of effect. In the 1940s, Thorndike proposed the following experiment. Put the rat in a little wire car in the entrance chamber of a maze, run it through the correct path of a simple maze and into the food compartment. Release it there and let it eat the morsel provided. Repeat 10 to 100 times according to the difficulty of the maze under ordinary conditions. And then put it in the entrance chamber free to go wherever it is inclined and observe what it does. Compare the behavior of such rats with that of rats run in the customary manner. Thorndike predicted that rats taken through the maze in a wire car would behave like naive rats. No learning would occur without the opportunity to respond and have that response reinforced. Another behavioral psychologist, Edward Tolman, disagreed. His prediction was that as the rat was carried through the maze, it would develop expectations about the maze's layout. For Tolman, individuals in new places form cognitive maps of their surroundings by developing expectations about what is where, then testing and refining those expectations through experience. Tolman predicted that the formation of cognitive maps would occur no matter whether the exposure to the maze was active or passive. In other words, it doesn't matter whether the rat explored the maze itself or was carried through, and it doesn't matter whether you're a driver or a passenger in your new neighborhood. In the 1950s, McNamara, Long, and Week conducted a version of this experiment using an elevated T-maze. The usual way that T-maze experiments work is that the rat enters at the bottom of the T, and when it gets to the end of the runway, it either turns left or right. If the food reinforcer is in the same arm of the T-maze on every trial, rats learn to choose that direction on almost every trial. And that's what happened with McNamara, Long, and Week's control group rats. Each rat in the experimental group traveled the same paths as a rat from the control group, only instead of running the maze itself, the experimental group rat was carried through on a little cart just as Thorndike described. If the control group rat turned left on trial 1, then the rat from the experimental group would get carried down the left arm of the maze on trial 1. In this way, rats in the two groups experienced the same consequences, but only the control group rats engaged in the operant response of choosing whether to turn left or right. After several trials of training, rats from both groups experienced extinction trials where they could choose where to go in the maze, but there was no food in it. It's important to note that rats had no way of knowing that there was no food available. If Thorndike's prediction that no learning would occur without a response was correct, rats in the control group would be more likely to choose the arm of the T-maze where they had been fed on previous trials, but rats in the control group would not. If Tolman's prediction that rats would learn where to expect food, whether they were able to choose where they went or not, was correct, rats in both groups would be more likely to choose the arm with the food. In fact, most rats preferred the arm that had had the food, and there was no difference between the two groups. In this case, Tolman's prediction was clearly correct and Thorndike's was wrong. In conclusion, active responding is not always necessary to learn an operant response.